Welcome to The Explainer. Today, we're going to completely demystify the magic behind large language models. If you've ever found yourself wondering how these massive AI systems actually come to life, well, you're absolutely in the right place. We're going to treat the entire complex process of building an AI just like a manufacturing assembly line. We'll strip away the jargon and show you the exact end-to-end flow of how raw, messy data is transformed into a highly intelligent system.
Okay, let's start by taking a look at this master blueprint. What we have here is the end-to-end flow, from a raw business idea all the way to a polished, talking financial assistant. Now, I know it might look like a huge web of complex engineering right now, but don't worry, we're going to walk the floor of this factory step by step so you can see exactly how every single piece connects. To make sure you don't get overwhelmed by the 10 crucial steps involved, we've organized our journey into 5 clear, sequential phases. 1. Goals and gathering data. 2. Designing the AI architecture. 3. The pre-training learning phase. 4. Evaluating and aligning behavior. And 5. Optimization and real deployment. Let's kick things off with Phase 1, Goals and gathering data. This is where we define our boundaries and collect our raw material. Step 1 is all about defining our goals and scope. Before we write even a single line of code, we really need to know what our AI is actually going to do. For our example today, we're building a financial assistant. We're giving it a specific size of 1 billion parameters, which you can kind of think of as the little memory banks where knowledge is stored. But just as importantly, we're setting strict boundaries. We are absolutely forbidding it from making stock predictions. Why? Because we want to drastically reduce the risk of it making things up. We're also giving it a context length of 4,000 tokens, meaning it can process a really solid chunk of a financial report all at once. Moving right along to step 2, we need to collect our data to build the corpus. Now, corpus is just a fancy tech word for the massive library of financial documents our AI is going to read. It's the model's fundamental knowledge source. If we feed it high-quality SEC filings and investor decks, it's going to learn real professional financial language. But here's a crucial secret about our AI assembly line. We can't just dump raw text into the machine. We have to push it through a step-by-step preparation pipeline to clean it up. First, we do deduplication, so the model learns general patterns rather than just memorizing the exact same document over and over again. Then, we normalize the formatting, filter out the useless noise, and tag it with metadata like the company name and year to give the text some structure. It's literally like thoroughly washing and chopping all your ingredients before you even think about starting to cook. Next up is Phase 2, Designing the AI architecture. This is where we teach the AI how to actually read and process language. Actually, we're going to jump ahead to step 5 for just a quick second because we really have to talk about tokenization. This is completely fundamental. You see, AI doesn't read letters like you and I do. A neural network is essentially just a massive calculator, so it only understands numbers. It uses a tokenizer to convert complex financial terms like EBITDA into a giant numerical code. Without this step, the AI is completely blind to our language. With all our text turned into numbers, step 3 defines the mathematical transformer architecture. Think of this as the wiring diagram for the AI's brain. The data flows through token embeddings to turn our numbered words into dense vectors, basically grouping words with similar meanings together mathematically. Then, multi-head attention acts like a giant spotlight, figuring out exactly how words relate to each other. For example, it connects the word revenue with growth, even if they're sitting on totally opposite ends of a long sentence. Finally, a feed-forward network processes all these relationships to capture really complex financial patterns. Now, what's really fascinating here is how this solves a massive problem. Remember, our AI just sees numbers. So to a math equation, the phrase profit increased and the phrase increased profit are made of the exact same numbers. They look completely identical. Positional encoding is the incredibly clever trick we use to inject word order information, giving the AI a way to actually understand the sequence and flow of language. Step 4 is where we take all of that theoretical math and implement it in actual code, using frameworks like PyTorch. This is where we initialize the weights. These are the core numerical values inside the network that will physically adjust themselves to capture patterns, like learning that higher revenue usually points to better performance. We also set up causal masking, which is a really neat trick that literally hides future words from the AI during training, forcing it to guess the next word properly. Doing this millions of times a second is what we call autoregressive modeling. All right, moving into Phase 3, the pre-training learning phase. With the brain built and wired up, it's time to send our AI to school. Step 6 is the real heavy lifting of the entire assembly line. We feed our massive corpus into the model.
and it tries to predict the next word over and over billions of times. So the crucial takeaway here is that by simply playing this colossal game of fill in the blank, the model miraculously learns core language structure, complex financial terminology, and deep cause and effect relationships. It isn't just memorizing facts, it's actively learning the underlying logic of finance.
But you might be wondering, how does it actually know if it's getting smarter? Well, it learns this using a loss function, which grades the AI's guesses. A high loss means the AI is clueless. A low loss means it's nailing it. If the AI guesses wrong, an incredible algorithm called backpropagation acts like a strict teacher. It mathematically calculates exactly which internal weights were responsible for the mistake and then forces them to adjust so the model gets smarter for the very next guess.
So, after weeks of this intense training on high-powered servers, our AI is highly educated. But that brings us to a terrifying question. What happens if the AI learns the structure of the math perfectly, but then turns around and confidently lies to our users?
And that question takes us perfectly into phase 4, evaluating and aligning behavior. Because let's face it, knowledge is completely useless if it's dangerous.
Those confident lies, we call those hallucinations. In creative writing, making things up is called imagination. But in the financial sector, where real money is on the line, a hallucination isn't just a glitch, it's a critical failure. We absolutely cannot have our assistant inventing fake revenue numbers for Apple or Microsoft. To prevent this disaster, Step 7 puts the model through rigorous evaluation. We check its perplexity, which is basically a measure of how confused the model is by new text. But more importantly, we test it on downstream tasks. We ask it real-world financial questions and measure its accuracy. We're actively hunting for hallucinations and biases, and we run human spot checks to ensure it is factual and, most importantly, safe. Now, if the model needs better manners or is getting a bit too creative, Step 8 brings in alignment. This happens right after the main training. We use supervised fine-tuning to explicitly show the AI perfect examples of answered financial questions. Then, using a technique called RLHF, reinforcement learning with human feedback, we literally have human beings grade the AI's answers, rewarding it for being factual, concise, and helpful. It's kind of like sending the AI to a finishing school for customer service. We are finally at the end of the assembly line. Phase 5, optimization and real deployment, getting this massive, well-behaved brain out into the real world. Step 9 is all about optimization. These models are incredibly resource-heavy, so we have to use clever engineering tricks like quantization. Without getting totally bogged down in the math, quantization is just a way of slightly reducing the decimal precision of our numbers. This dramatically shrinks the model's physical memory size, making it actually affordable to run on our servers without losing much intelligence. We also use a KV cache to remember previous calculations, which massively speeds up how fast the AI can type out its answers for you. And finally, Step 10 is deployment, the moment of truth. The model performs what we call inference, which simply means it's now actively generating answers to real user questions. We monitor its latency to make sure it responds quickly. And crucially, we set up a feedback loop. By collecting real usage data, we ensure our AI doesn't just sit there getting stale, it keeps getting smarter and more refined every single day it interacts with users. Let's synthesize the core intuition of what we've just built together today. Look at how beautifully simple it really is when you break it down like this. The pre-trained data dictates what is learned. The training process, with its losses and gradients, dictates how the knowledge is learned. The attention mechanism figures out the relationships. And the parameters? They act as the physical vault where all that knowledge is locked in and stored. All of this culminating in deployment, where we actually get to use it. So now that you know the magic of AI is really just an incredible assembly line of structured data, clever math, and human alignment, I want to leave you with a thought. The very next time you ask an AI for help, remember that you are triggering billions of parameters that were carefully shaped by this exact process. How will these mathematical weights and carefully aligned biases actively shape the future of how you interact with information every single day? Thanks for joining me on the factory floor today for this explainer. And as always, keep asking the big questions.